original data, even if this one doesn't look any better. I can put that syringe back. So while we're waiting for that one, we may as well go over and inject one of the t-butyl samples. So I'm going to do the same thing. I'm going to point this to my folder. PC Lever, 2020 Fall Lab. I'm going to go to single run, sample login. I'm going to call this DCL-10-TBU-. And since I have two different samples, I'm going to say 15S, so that's the 15-second run, -1. This is pointing at Jacob Paxson's folder. He must have been the last person to run it. So I'm going to my folder, 2020 Fall Lab, and I'm going to call this t-butyl halides. Oops. Short. And just in case I have to do the second one, I'm going to call it t-butyl halide short 1. So this is not one bromobutane and one chlorobutane. Backspace that. Carrier gas pressure is 90 kilopascals. That's helium. Split valve is open 6 turns, and this is a mixture of t-butyl bromide and t-butyl chloride. So I can OK that. And now I can press start. So here's my 15-second t-butyls. And I'm going to do the same thing I did with the n-butyls. And flush the syringe with the sample. I don't know if you can see it, but this syringe tip is bent, and so it's squirting out sideways. Probably can't see that. The camera's not that sensitive. Pump it a few times, again making sure that I don't get the needle into the solid. Pull up 1 microliter. Cap that back. It says ready standby, so it's ready for me to do my injection. Same drill. Push it down, depress the plunger, pull it out, press start. That will send it from ready standby to acquire. And I can now wash my syringe out with pentane, so it's ready for the next sample, which is the 35-minute with periodic shaking, where we may have reached equilibrium. You can definitely see that syringe needle has been bent a couple of times and straightened. Probably hit some metal at some point. So there's my pentane, and then I should see my t-butyl chloride and my t-butyl bromide coming out. Looks like we've got pretty clean separation there between the solvent peak and that first peak, assuming that first peak really is the t-butyl chloride. And then we got a second peak here. Maybe the t-butyl bromide. The second n-butyl sample is done. So I can go to post-run analysis, n-butyl halides 2. And it looks like I have pretty clean separation. It's detecting n-butyl chloride in 3 different locations, but I know that only that 0.965 peak really is the n-butyl chloride. So I can edit this for method, and I'd like to turn on the integrator after that second peak comes at 0.93. So I don't really need the reject peak command. I can delete that. But if I don't turn the integrator on until 0.93 minutes, I can make sure that it doesn't pick up those extra peaks. And now I can go to the compound table if I want to and edit and tell it that it's at 0.965 for the t-butyl chloride and 1.224 for the t-butyl bromide. And again, it's about a 20-80 mixture, so it's a little bit different this time around. It may be that the peaks were not as cleanly separated as they could have been, but still it's about a 1:4 mixture of chloride to bromide. So I'm going to save that data file. And at this point I'm through with this. I don't need the halide mixture. So I got away with dumping most of it on the counter and doing a benchtop extraction and still having plenty of data to work with. So now it's time to plot this. We're going to go to the top menu. We're going to go to where it says Report Generator. And we're going to open the format file that we will find in the GC lab. I thought it was going to be in there. I thought there was a report forms in the GC lab. Maybe not. Yeah, that's not it. Well, let's try something else. Because I believe on the student share there's also a folder called OChem GC report forms, and there should be one called substitution reactions. There it is. Hopefully this will actually show us what we want. Right now we're in the reports tab, so the data files are not visible, but if I go over here to the data tab on the far left, there are my two data files. And I can simply click and drag it in. This is a mixture of n-butyl halides. Looks like I need to make that window a little bigger so I can actually see my mixture of n-butyl bromide and n-butyl chloride that I typed in. So there's my sample information. My chromatogram is here. Make that a little bigger. And then my peak table down the bottom gives my retention time, my area percent, and my compound name. And that's all I really need. There's no need for it to be as big as it is. I can actually pull that to the bottom and I can make the chromatogram a little bigger. I really don't need to see the entire 2 minutes, but it's not doing any harm to show the whole thing. I'm going to save this format file, and then I'm also going to print it to a PDF file. Qt PDF Writer is the correct printer. It's going to ask me where I want to put it, and I want to put it in my 2020 Fall Lab folder called n-butylhalides.pdf. That seems like a reasonable thing to call it. My t-butyl halide short just appeared. So that was the n-butyl halides. I'm going to drag the n-butyl halide 2 into the report form. You'll see that changed a little bit because of the slightly different temperature. Slightly different ratio here, more like 20 to 80 versus 19 to 81. Drag that guy up here on scale. Save the format file, and I'm going to print that. And butyl halides 2. At this point, I'm done with this instrument. So I'm going to go ahead and reset that. I always reset it when I'm done so that it's pointing at just the J data folder. So the next time it opens, it will automatically be pointing there. I'm going to reset the post run so it's also pointing at J data. You can see that some people accidentally stored their DC right in the J data folder, which is not usually considered correct. So now I don't need the real-time analysis anymore because I need to just let this cool down. I'm going to turn that off. But I do need to let this thing cool. So I'm going to turn my injector temperature to 25 degrees, my detector temperature to 25 degrees, and my initial column temperature to 25 degrees. And then I'm going to monitor the detector. The detector cools the most slowly. So injector 25, detector 25, initial temperature 25, monitor detector. I can turn off the heater. Don't need the heater anymore. And I'm just going to watch that detector. I don't want to turn the instrument off until the detector is well under 100 degrees. And I don't need the CBM anymore. I can turn that off. And really, I actually don't need the computer anymore either. So I'm going to go ahead and shut the computer down. So that instrument is through. And so as not to waste hydrogen, I'm going to turn the hydrogen flow off so it's not flowing to this instrument anymore. I leave the air on because the air cools the detector and makes it cool a little bit faster. And I leave the helium on because we want the column to have helium flowing through it while it's being heated. So I'm going to go ahead and go to sample login. And to change this 15 seconds to 35 minutes, 35M, first piece of data on that, change my data file so it says long instead of short. Everything else is the same. Carrier gas pressure is 90 kilopascals helium, and it's split 6 turns, and it's still the same mixture. I'm going to OK that. And while that second one is running, that's my 30-minute. It was actually 35, you recall from the other video. I want to make sure I don't get any of that solid. So I'm going to kind of pull that out with my finger. That was where it splashed a little bit. Remember, this one foamed pretty vigorously. So I'm going to do the usual flushing of the syringe with my sample. Pumping, taking up 1 microliter. It says ready standby, so I can insert my syringe, press start, and while it's acquiring that one, we can have a look at the other file and see what it looks like. It's always a good idea to put the syringe back in its little chamber because they kind of like to roll and commit suicide falling on the bench. So it looks like I got my solvent peak and my chloride, and there's my bromide. So it appears that these have also been successful. Put my pentane back. It takes about an hour for the detectors to cool down enough that they can be turned off. But fortunately, you won't need to be here for that. So yeah, 185 so far. Takes a little while. So this is acquiring. Minimize that. We can open up the post-run software. And I'm going to point that to my folder. 2020 Fall Lab. And the t-butyl halide short. We'll open up that file. And you can see it actually worked out pretty well. Solvent peak, there's the t-butyl chloride and the t-butyl bromide. And it looks like we're at about a 66 to 33 ratio. We are showing an extra little peak there. It's integrating all the way across that, which is not necessarily what we want. Not sure what that is. Could be a little double inject. I thought I was pretty clean, but maybe I wasn't as clean. Or there could have been a little bit of carryover from the hexane as opposed to the pentane. It's probably not enough to throw things off a great deal. So if I go to edit mode, you see under compound here, it was 0.7 minutes last year, pretty close to 0.68, 0.86, 0.9. So those aren't, it's not really necessary to fix those. And if I go to integration, for method, right, I was turning the integrator on at 0.65 minutes, which is fine because 0.686 is where it comes off, so we don't see the solvent peak. I could try to get it to separate those two peaks by messing with the integration parameters.